Okay, so hoping that the volume is okay. Hi, I'm Ray, and I'm going to share about my experience of building a computing service in my department. So, wish that you guys can know more about this kind of system after this talk. So, before getting to topic, I want to introduce myself. My name is Jun Huang, and you can call me Jun or Ray. And Explorer is my GitHub ID. If you want, you can search me. Yeah. And I am currently a graduate student in NYCU. And my research interest is something about infrastructure and IT, something like that. And in addition, I am also a team member in NYCU CSIT. If you don't know what it's okay. I will explain it later. So let's get into a topic. What is a computing service? In my definition, I think it's a service that admin will handle hardware. I think most of services will fit this. But the second one is it will provide users computing resource to execute programs. So fit my definition. A workstation and a supercomputer make all a kinds of computing service. So we need hardware for this service. So what's the resource we have? In my department, we have more than 40 nodes with GPU. I want to clarify what's a node here. It's a computing resource unit. A personal computer, a server, or a virtual machine are all kinds of nodes. And the resource we have is only personal computer. So it's not that expensive. But it is also not cheap. So why a student like me can handle resources like this? Because we are actually a team. We call it IT Center in NYCU Computer Science Department. And the abbreviation is NYCU CSIT. We are managed by students, and including graduate and undergraduates. And we have several teams maintaining several critical services in my department. Including network, mail, and so on. And among them, we have HPC team for this kind of service. So why we provide computing service? Because we have some target users. Our target users are students who enroll in CS course. They need to write assignments, and they may have insufficient resource. Like our biggest user, parallel programming. They will use several methods to make programs faster, including multi-thread and MPI, which use multi-node. But a user may have no multi-node for them to run programs, so they need this environment. And GPU parts also used here, including machine learning related codes. They will use GPU for training models. And parallel programming also use CUDA and OpenCL to do some speed up. And another important thing here is that parallel programming will determine their grades, the assignments of their grades by the performance. So they must need a consistent environment for doing assignments and grading assignments. So that it won't be unfair if you actually write in a laptop, but it actually run a personal computer or run on a server. Actually, before I handle this service, there is an original one. And its architecture looks like this. If there are two cores applied for our service, we will split into two parts, split compute node into two parts, and we will give them access so that they can directly log into the nodes and run their programs. But this kind of architecture means many problems. The first one is let's just log into LAN just like a workstation, and In parallel programming, it has about 130 students, and we only have 40 compute nodes, so it has a severe resource contention issue. I will take an example about what is resource contention. If a user logs into that compute node and run a multi-thread program, everything works well. But what if the homework deadline is coming? Many people log into a certain nodes because there are so many people and the resources are limited. They may run the multi-thread program at the same time, and you will find that the CPU can handle that, and the performance will be very poor. So do you remember that parallel programming will use a program performance to determine their grades? So in this situation, students will unable to check whether their codes are good or not, because I run this time, it works slow, maybe the code is broken, and this time I may run slow because of other users are also running. They are unable to check these things. And teacher assistant also use this environment to grading assignments. So if they are grading and there are other students running program, the performance of the grading student will be influenced. So we must fix this issue. So our goal is to provide a new system that supports running each job exclusively. Just like down here, if the program is running, other programs want to run on the same node should be wait in queue instead of directly run. Another one is because we support more than parallel programming, we also need to support other cores. So we want it supports multi-user and multi-cores. And we want that they can use all compute nodes instead of split into several groups. So here I want to talk about Slurm. What is Slurm? Slurm is actually an open source system, and its full name is very long, like this. And it's used by more than 60% of supercomputers. And I think it's just help you manage your job, including login node, submit job, and you will allocate resource like how many CPU cores you want. Then you will schedule to compute node because there may be 3 compute nodes available. You will check which one you should run on it. Yeah, and finally, it will execute the job and return the result. Slurm has 4 kinds of rules. They cooperate together and make our job management works well. And why we choose Slurm? Because it can resource allocate. I should say this part resource allocation will check whether the resources are available or not. If the resources are available, it will wait in queue, and that's what we want. Just run each job exclusively. And the second goal is support multi-user and multi-cores. Slurm also supports multi-tenancy so that we can finish the second goal. The last one is it is also used by many supercomputers. So we think that its community won't be small, so that we can Google something to get some help instead of debugging by ourselves. So here I want to talk about some detail about how Slurm works by introducing its 4 rules. The first rule is login nodes. I think it's like a counter staff because it's the first station where user access, and the user will submit job here. Then what login nodes do is do some simple check and forward your job to a controller. Then why it's a controller? I think it's like a manager because you need to maintain all jobs from different login nodes, and it will decide a job priority for them. If your job has the highest priority, it will ask the backend, which is the compute nodes, to run the jobs. So the next one is compute nodes. It's similar to worker. Just what you do is just accept the request from controller and run and return results. The next one is DB interface and database. DB interface is like a content because it helps whole student cluster to read and write database. And it will write something about job, about accounting, like some user info, user limit, and some job info like how many jobs are executed, and the job use how many resources, and something like that. So now you know 4 kinds of roles. Now I want to tell you about a very simple summary how to build out this student cluster for service. First one, you need to prepare nodes. You need to install operating system for them. Then second step, you need to install necessary packages for different roles. This is a screenshot from their quick start guide from student documents. You can see, let me take an example. If you want to run that node for login nodes, you should install this two package. And after installing, you need to set configuration for them. Then that's very simple summary. So after working these things, you should have a great student cluster. But don't forget that we have more than 40 nodes in our department. So if we set up everything manually, it will cost a lot of effort and time. So we wrote Ansible playbook. If you don't know, do you know what's Ansible playbook? You can think that it's like a short script that can run on many nodes. So it can help us install packages and set configurations for them. And after setting these things up, you will have a functional student cluster. And if you are interested, maybe you can find my GitHub. There is a student playbook repo. Yeah. So here I want to use a real example about how these roles cooperate with each other. First one, user will submit job request with a student comment. S1 is created by in student packages, and it asks student to run this job. Then the bcast option is for copy file to compute nodes. Then the big N means how many nodes you want. Then it will ask to use MPI to execute it out of this program. Then after executing it, it will submit a job. Then login nodes will help you forward to controller. Controller will maintain a queue and check whether this is has the highest priority. It will schedule to compute nodes and run. Then it will return a result. Sure, results may be like this, but that's not the end. It will notify the controller a job is finished, and it may remove a job from queue. And it will provide some job info like how many time the job collapsed and how many resources the job used. then it will write into database. Here, I want to talk about a program location issue, because I just said a bcast option, which is used to copy file into compute nodes, because login nodes and the compute nodes are different nodes. So to execute a program, they must have the same file. You may think just copy it, but it's not that convenient. You need to add this option, and the copy also needs time. And the last thing is you will waste the storage, because you need to put this file on all the nodes, even if it's just a file. So here we use network file system, which is NFS, to fix this issue. It's just like connecting to the same storage server, so that the login nodes can compile the ADAS on it, and the compute nodes will read from the storage, so that the bcast option can be removed. Then you may think, how about library? If the executable is dynamic linked, how do I deal with library? So actually, the answer is very simple. Just install them on the network file system. But for multi-cores, it's not that simple, because different cores may need different package. May need the same packages with different version. Like maybe a course wants a Python version with 3.10 and another wants 3.12, which is hard to handle with the built-in package manager. So here is a list of how we choose a good package manager. Yeah. The first thing is you need to fix our needs to handle a package with different versions. The second one is reproducible environment. We wish that TA can provide me with a manifest, so that we can just install a thing on the manifest, and everything works well. The third one is we want user, which is students. They may don't know the knowledge of these things, so we hope that it can easily activate their course environment. The last one is we don't want to build packages on ourselves, so we want it provides official package binary cache, so that the install speed will be faster. So here just a list of package manager we use, and now we use Nix and Conda, and I think I can simply tell something about that. Anyway, now we use Conda for machine learning related course, because our TA like to use that, and the manifest is written in YAML. It's very long, so it's hard to port into Nix, so we still use Conda. And about Nix part, because it has, I think their community is relatively large than the previous two. So its packages are very new, and binary cache are also, I have never found a situation that I want a package and the Nix doesn't have. Yeah. So I think that's why we choose Nix and Conda. So we finished everything set up. So we can finally convert from the old architecture into new one. So with Learn Lake, whole students can log into a login nodes and submit their jobs to whole compute nodes. And about a resource contention issue, they originally log into the send node and run programs, and the performance will be poor. But now, if a program is running, another program want to run on the send node will be wait in queue. So everything looks fine. Is it? After getting to a production, we still find some issue. And I will pick a most important one here because maybe the time is not enough. So if a user keeps sending Java requests like this, keep sending, and the whole resource will occupied by him, and all the users can use. So how do we address this issue? Actually, Slurm has a quality of service settings. It's very simple. It's just setting limits to users, and whenever a user sends a request, it will check this limit. So we have several things can be set, and about the previous example, we just need to set the max submit job here, so that it can no longer send more than this limit. So what if we set into 1, so that it can only send one request, so that other resources can be used by others. And I think that's the issue. That's the most important issue I want to talk about. So here is Q&A time. Thanks.